This is Jennifer, Assistant Professor, Data Science and Business Systems, SRMIST KTR Campus. In this tutorial, I will discuss with you through the most important data structure interview tips on Stack. Stack is a linear data structure. It follows a particular order in which the operations are performed. The order may be either LIFO, last in first out, or first in last out. Last in first out implies that the element that is inserted last comes out first, and first in last out means that the element that is inserted first comes out last. It behaves like a stack of plates where the last plate added is the first one to be removed. So here, pushing an element onto the stack is like adding a new plate on top. Popping an element removes the top plate from the stack. Operations on stack are push and pop. Push means inserting element into the stack. Pop in the sense removing top element from the stack. Here, the insertion and deletion takes place at one end of the stack, that is called as a top of the stack. Here, top is a pointer. It always points to the last element in the stack. So next we can discuss few problems to solve by using this stack concept. Here, a stack question is, stack initially contains from bottom to top 1, 2, 3. The following operations are performed in some order. After performing these operations, what will be the final content of the stack? So next we can see how we can solve this problem. So first operation for initially, stack contains 3 elements, 1, 2, 3. The following operations are performed in order. First operation is push of 4. Push in the sense insertion. Insertion takes place at the top of the stack. So after pushing 4, the stack looks like this. Then pop of next operation, pop. So after popping, that means the top elements gets removed. So after popping, the stack looks like this, 2, 3. Then again, third operation, that is push of 5. Push in the sense we are going to insert 5 at the top of the stack. So after insertion, 2, 3, then 5. Then the last operations, so push off, pop off plus pop off. So 2 times we need to pop the element from the stack. So after popping 5, first pop off, then it returns 5. Then plus second pop, it returns removing top element, next top element from the stack. So after popping 2 elements, 5 plus 3, what we get? 8. Then the element 8 need to be pushed onto the stack. So after executing the last operation, after executing last operation, the stack look like this, 1, 2, 8. So the final content of the stack is 1, 2, 8. So the next question, second question, 2 stacks are given, S1 and S2 have the following contents. This also the elements listed bottom to top. So S1 like this, S1, S2, 1, 2, 3. The stack S2 has two elements, 4 and 5. Next, we need to do all the operations one by one. So first, push 6 onto the stack S1. So after executing the first operation, the stack S1 is look like this. 1, 2, 3, 6. Next, second operation, after performing pop on S2, the stack look like this. S2, we need to pop. We need to remove the, so insertion and deletion takes place at the top of the stack. So after pop S2, the content of S2 is 4. 5 gets removed. The next, third operation. So third operation, sequence of operations are there. First we need to pop S1. So pop S1 in the sense 6. Then pop S2, 4. We need to add these two elements. We can get 10. During the third operation, we need to push this 10 with the existing element in the stack S1. So the existing elements are 1, 2, 3. Then the new element 10, we need to push it onto the stack. So after executing third statement, the stack S1 looks like 1, 2, 3, 10. The next operation, fourth operation. So next, first we need to pop S1, that is 10. Then this 10 to be pushed onto the stack S2. So already the 4 gets popped, so the empty stack, so S2, we need to push this 10 into the stack S2. Pop it from S1 and push it onto the stack S2, 10. So the next, fifth operation. So we need to pop S2 and S1. Okay, yeah. So then 10 from S2, 3 from S1. So the result is 13. Again, we need to push it onto the stack S1. So S1. So after performing the fifth operation, we can get 1, 2, 13. Then next, last, sixth operation, we need to push 7 onto the stack S2. So 7. What are the final content of the stack, bottom to top? In S1, 1 to 13, S2, 7. This is the correct answer. Next, I am going to introduce few things about expression tree. See, expression tree is a binary tree in which the internal node correspond to the operators and each leaf node correspond to the operand. So the one example, 3 plus 5 plus 9 star multiplication 2. It would be the corresponding expression tree is mentioned in the right hand side. How we can construct this expression tree? So to construct expression tree, we can use stack. While constructing expression tree, first we need to scan the expression from left to right one by one. If a character is an operand, we need to push that into the stack. If a character is an operator, we need to pop two values from the stack and make them a child and push the current node again. In the end, the only element of the stack will be the root of an expression tree. So here, next question. The following postfix expression is given. If it is converted to an equivalent fully parenthesis infix expression, which of the following is correct? Here we are going to convert the postfix expression into an infix expression. For that, we need to construct the expression tree. How we can construct the expression tree for the above postfix expression? So first we need to draw a stack first. Then we need to scan the character from left to right. First is the character. If a character is an operand, push that into the stack. So we need to push it onto the stack. Push it into the stack. We need to create one node tree, that is A. Then next, second one also a character. If a character is an operand, push that into the stack. That is B. Then third one is the operator. If a character is an operator, we need to pop two values from the stack, make them its child and push the current node it again. Third one is the operator. So we need to pop two values from the stack. We need to pop two values from the stack and make them its child. So the operator is plus. We need to push this plus into the stack, and already popped elements are A and B. We need to make these two as a child of this operator plus. Then next one is the character. So character in the sense, we need to push it onto the stack. C, then D. Next also a character, we need to push it into the stack. E. The next one is the operator. If a character is operator, we need to pop two values from the stack. So in this scenario, we can pop, this is for plus, this is for C. When we find a operator, we need to pop two values from the stack. So here the operator is plus. So we need to pop two values from the stack. That is D and E. Already this plus has two child. One is A, another one is B. Next, again the next character is also a operator. So we need to pop two values from the stack. So multiplication, in this scenario, we can pop last two values from the stack. So the last two values are C and plus. So already value C, make them as a pop 2 values and make them as a child. C here plus D and E. So already existing element into this stack is plus, it has two child, one is A, another one is B. Next, the last character is also a multiplication. So if a character is an operator, pop two values from the stack and make them its child and push the current node again. So as per this rule, when we find this multiplication, we need to pop two elements from the stack. So one is, the left hand side is plus, the right hand side is multiplication. Plus has two child, one is A, another one is B. Then this multiplication has two child, one is C, then plus and D, E. So this is the expression tree for the given postfix expression. From this expression tree, how we can derive the infix expression? So first, the last leaf, that is plus. So plus D and, plus is for D and E. Then this statement is multiplied with C. Multiplied with C. Then this statement is multiplied with one more expression, that is A plus B. This is the way we can generate the infix expression. So the corresponding infix expression of the given postfix expression is the third one, that is A plus B star, that means multiplication, open parenthesis C, multiplication, open parenthesis D plus E. So the next question, fourth question, here we are going to evaluate the postfix expression. Here 1, 2 plus 12, 3, division, multiplication, 5, subtraction. How we can evaluate this expression? So for that, first we need to draw one stack. Scan the expression from left to right one by one. If it is an operand, you need to push it into the stack 1. Second character, operand, push it into the stack. Then when we find the operator, we need to pop two values from the stack and perform the operations. The result is need to be push the current node again. Okay, so based on that rule, when we find the operator, we need to push it, we need to pop two elements from the stack. So 2 and 1 is popped, 2 plus 1. The result, that is 3, need to be push it into the stack. Then next one is the 12. So we need to push it into the stack, 3, 12. Then next one is the 3. 3 also a character. We need to push it into the stack. 3, 12, 3. Next one is the operator. When we find the operator, at that time we need to pop 2 elements from the stack and perform the operation. So based on that, 3 division 12, the result is 4. We need to push 4 into the stack. Then next one is the multiplication. So when we find the operator, that time pop 2 values from the stack and perform the operation. The result need to be pushed it into the stack. That is 12. Then 5. That is a operand, so we can push it into the stack. Then subtraction. So we need to pop 2 values from the stack. 5 minus 12. The result is 7. So the answer is 7. So next, convert the following arithmetic expression into a postfix form. So for how we can solve this problem. So here the expression need to be scanned from left to right one by one. If it is an operand, to solve this problem, we need to create 2 stack. One is the input stack, one is the output stack. If it is a operand, if a character is operand, we need to directly place it into the output stack. So the first one is the A. So A need to be placed into the output stack. So the next one is the operator. So the operator needs to be inserted into the input stack. So minus. The next third one is the again character. So we need to place it into the output queue, output stack. The next one is the again subtraction. So when we find the operator, we need to check the existing operator in this stack. We need to compare the operator precedence of these two. Okay, minus and minus. Both operator has an equal precedence. So at that time, we can pop one operator out from the stack. So here the third one is the next operator is subtraction. These two are equal precedence. At that time, we need to remove one operator from the stack. Next, open parenthesis. If an opening parenthesis found, we need to push it into the stack. Then, next one is the again open parenthesis, push it into the stack. Next one is the character D. So it is an operand, so we can directly move it into the output stack. The next one is the operator, so we can insert into the stack. The next one is the again operand, directly we can place it into the output stack. So next one is the closing parenthesis. If an closing parenthesis found, pop operator from the stack to the output stack until the opening parenthesis is encountered. If an closing parenthesis is found, pop operator from the stack to the output stack until an opening parenthesis encountered. Here we are found the closing parenthesis, so we can pop the multiplication and place it into the output stack. So after this, the input stack look like this. Subtraction is already existing, one open parenthesis. Then next one is the division. So operator we can push it into the stack. Then F, so need to be directly we can place it into the output stack. Next one is the closing parenthesis. If an closing parenthesis found, pop operator from the stack to the output stack immediately until an opening parenthesis encounter. So based on this rule, we can pop division and we encounter the opening parenthesis. So after this, the stack is look like this. Okay. So the next one is the plus. So listen here. We need to compare when we insert one operator into the stack. At that time we need to compare the current operator with the existing operator. Here these two has an equal precedence. In this, but different operator. In this scenario, we need to check its associativity. So plus and minus left to right associativity. So first we need to perform the left operator. Left operator in the sense first one. So we can pop subtraction symbol from the stack and push it onto the push plus into the stack. So the next one is the B. B, it is an operand, so we can directly place it into the output stack. Then multiplication. So multiplication is operator. We need to push it into the stack. Before pushing, we need to compare the operator precedence. This multiplication has a higher precedence, so we can keep this multiplication above this lower precedence plus. Then C, operand. So directly we can. Now we came to the end of the expression. So when we reach the end of the expression, we can pop all the elements from the stack one by one. So the existing element from the stack is multiplication first, comes out first, then plus. Now after removing, the stack is empty. Now we can stop our algorithm. The corresponding answer is AB minus DE star F slash minus BC star plus. So dear learners, mastering data structure is not about memorizing solutions. It's about understanding patterns and thinking through problems clearly. Thanks. Practice consistently. Thanks for watching. So don't forget to like, share and subscribe for more interview preparation tips. Thank you.